y equals 0. Notice it was a y. Okay. Last one for like this. Not last one. Last one like this. Let's call it g of x this time. 3 over x squared minus 5x minus 6. Pause the video. Try it on your own. So we set the denominator equal to 0. X squared minus 5x minus 6 equals 0. How do you solve this equation? Factor. X minus 6, x plus 1. We're solving, so we switch the sign. X equals 6, x equals negative 1. So the domain is all real numbers except x equals 6 and x equals negative 1. Range. Again, the range doesn't change very much. You can get anything out of that except 0. Real numbers except y equals 0. Okay? All right, we're going to change it up now. Let's change this up. Number 6. Slightly different. F of x equals x over x minus 7. Very slight change. Start with the domain. Pause the video. Just like before, x minus 7 equals 0. You're not allowed to have 0 in the denominator. Solve, and you get x equals 7. So the domain is real numbers except x equals 7. Now, range is a little different here. The problem area was 0. Why? Can you solve x over x minus 7 equals 0? Is there a number you can plug in here? There is. If you try cross multiplying, x times 1 is x. 0 times x minus 7 is 0. Were we able to solve the equation? Yeah, 0. If you plug in 0, f of 0 is 0 over 0 minus 7. 0 over negative 7 is 0. So the domain here is all real numbers. You can get anything. It may not be a nice number, but you can figure out any number for this equation. The range, is all real numbers. All right, next one. Number 7. X plus 5 all over x squared minus 9. Oops, f of x equals. Pause the video, try it on your own. This kind of takes everything we've done so far. Domain, all real numbers except, what do you get here? X squared minus 9 equals 0. Oops, minus 3. It's a difference of two perfect squares. X equals negative 3, x equals 3. And I'm super lazy, so when I write this out, instead of x equals 3, x equals negative 3, x equals plus or minus 3. Range. What do you think? All real numbers except. Is there an except here? Can we get 0 out of this? X plus 5 over x squared minus 9. Can we solve it? Try. Try cross multiplying. See what happens. 0 equals x plus 5. Is that solvable? Yeah. So why were these two solvable and the others weren't? There was an x on top. Okay. So here's your range rule. Okay. Here's your range rule if this is like struggle, because I know this is struggle for some people. Okay. If there is no x in the numerator, the range is all real numbers except y equals 0. Sorry, this is supposed to be a y. If there is x in the numerator, the range is all real numbers. Okay, so that's kind of your just general, if you want notes to try to remember. I'd prefer you understanding it, but I don't judge. All right, so now we're done with radicals. We're going to do two more problems, one more type. Okay, The last type I want to work on is radicals. F of x equals radical x. This is similar, but not quite the same. What are you allowed to plug, or what are you not allowed to plug into a radical? What can you not have? Negatives. So where is the cutoff for negative numbers? 0. 0, 1, 2, -1, -2. So it's very similar because a lot of students say, oh, just set the inside equal to 0. Technically what we're doing is we need the inside to be greater than or equal to 0. Remember, you can take the square root of 0. A lot of students think you can't. We need the inside to be greater than or equal to 0. So what's the inside here? X is greater than or equal to 0. So that's actually the domain, but I like writing it as an interval. So if the number is greater than or equal to 0, think about the number line. There's 0, and I'm shading which way? To the right. So the smallest number is 0, and the biggest number is infinity. You can't go smaller than 0, but you can plug in 1, 2, 3, a billion, a trillion, a Google. Okay? All right, the range. What do you think the range is? What can you set equal to a radical? Can a radical equal 0? Yes. Can a radical equal -1? What can you plug in here and get a negative out of? Nothing. So what do you think the domain is? It's the same. Or the range, sorry. The range and the domain are the same in this case. Because remember what a radical looks like? We graphed these in Algebra 2. It's just that. It's a sideways parabola. It's half of a sideways. So farthest left, infinity. Farthest left, 0. Farthest right, infinity. Lowest 0, highest infinity. All right, one more and we're done. What is it? Okay, f of x equals x plus 10 minus 3. Okay. Now, what is the domain? What did I give you as a rule? The inside is greater than or equal to 0. The inside, x plus 10 is greater than or equal to 0. You ignore the -3. The -3 has nothing to do with the domain. We don't care what's on the outside. It's only the inside that we have to worry about. So we subtract 10 on both sides. X is greater than or equal to -10. So what's the domain? -10 to infinity. Now the range. Now here's a quick rule. Here's a quick rule.